Today's topic of discussion is time and work. We shall try to introduce the concept of time and work for grade 8 students of CBSE. So what are these two key words, time and work? These are easy to understand, these two key words. So what is work? Work stands for anything like painting a wall, plowing a land, building a house, or writing a book, so on and so forth. And the time stands for the total time required to complete this work fully. Now something is missing between the two. What's that? The doer. Time and work. But who is connecting the time and work? It's the doer. Doer could be a person, two persons, or a group of people. So let us set the context of this important topic with two people, Amit and Mohan. They have decided to paint the walls of their room. The first day they have selected two walls, each one doing a wall opposite to the other. It is a rectangular room, so the opposite walls are exactly same in size and area. They also want to record how much time they are taking to finish the work. So they have set up a clock. After completing the job, Amit looked at the clock and found he took 2 hours. Mohit has not finished yet. He continues to paint his side and completes it in 3 hours. So what do you think? Who is more efficient? Obviously, who has taken less time. That is, Amit is more efficient. Here the students can do an activity. Two of them will individually carry a heavy weight from one end of a corridor to the other and compare the timing of the two. Suppose one took 30 seconds and the other 45 seconds to reach the other end. Now let the students think who is more efficient, the one who reached in 30 seconds or the one who did the same distance in 45 seconds. This activity may be done even at the beginning of the chapter as an entry ticket, depending on the discretion of the teacher. What is efficiency then? Efficiency is how fast or effectively one can complete a work as compared to the other. How is efficiency determined? It is the rate of work. That means amount of work done in unit time. This unit time could be either second, minute, hour, week, day, so on and so forth. So let us see what we have discussed till now. What is missing is the doer. Doer could be one person, two persons, or a group of people. And what is efficiency? How fast and effectively one can complete a work as compared to the other. And how is efficiency determined? Efficiency, as we have said, determined by the rate of work. What does that mean? Rate of work? This is the amount of work done in unit time. And as we said, it could be 1 second, 1 minute, 1 week, 1 day, 1 hour, so on and so forth. Now we shall try to understand the relation between these three words: time, work, and rate of work, which means efficiency. They are denoted by letters T for time, W for work, and rate of work by R. In our example, Amit finished the work in 2 hours. So the total time required for Amit was 2 hours. The total time required for Mohan was 3 hours. And what was the work? It was the painting of the wall. So when the wall is painted, the whole work is done. Whole work is always taken as 1 unit of work. R is the rate of work, as we already said. It is the amount of work done per unit time. So in this example of Amit and Mohan, how to calculate the rate of work? For Amit, in 2 hours, he finishes painting the wall. He finishes the whole work, which we take as 1 unit. That is 1 unit. So in 1 hour, how much he will finish? He finishes painting if this is 1 unit, in 1 hour he finishes 1/2 unit of the work per 1 hour. And this is his rate of work. Amit's rate of work, which is also equal to Amit's efficiency. And for Mohan, in 3 hours, completes 1 unit of work, that is the whole work. Then in 1 hour, he can complete 1/3 unit of work. So Mohan's rate of work is 1/3 of the wall per hour, which is equal to his efficiency, Mohan's efficiency. Just try to understand this clearly. It's a little confusing, but just go through how to calculate the efficiency of individual person or a group of people. So how to write a working formula between T, W and R. T is the time, W is the work, total work, T is the time required to complete this work, and R is the rate of work, amount of this work done in 1 hour. So what is the relation? W is equal to R into T. Why? R is the rate of work done in 1 hour, and the total time required by Amit is 2 hours. So in 1 hour he has done half of the work. In 2 hours he will do the complete work. So for Amit, the work done will be rate of work, that is half of the wall per hour, into time 2 hours. So the work comes as 1 unit. Total work is always taken as 1 unit. And for Mohan, again W is equal to R into T, and for Mohan, rate of work is 1/3 of the wall painted per hour into, he took 3 hours time. So 3 hours and 1/3 of the wall per hour. So total work done is again 1 unit. So now to get R, we have to divide total work done by total time required. And as total work is 1 unit, so 1/T. Rate of work is inversely related to the total time. The faster the rate of work, then the time required will be less, and slower the rate of work, time required will be more. So it is inversely related. Efficiency increases, time decreases. If efficiency decreases, the time will increase. Next is, what about T? T is equal to W by R. Again, W is always represented by 1 unit. So 1 by R. So now what is the relation between number of people and the time of work? Let us see. Number of people working together is inversely proportional to the time taken to complete the work. As we already saw, R or rate of work is inversely related to T. So, number of people increases, that means rate of work increases, efficiency increases, time decreases. When number of people are less, efficiency decreases, then the time to finish the job increases. So let us try to understand all these key concepts with a simple example. A can complete a work in 10 days, while B can complete the same work in 15 days. If A and B work together, how long will they take to complete the work? That is the question. At a glance, it will appear it's an easy sum. A completes the work in 10 days, B completes the work in 15 days. So together they can complete the work in 25 days, 10 plus 15 days. A plus B complete the work in 25 days, but hold on. Think for a while. When they are working together, will they take more time than the individual times or less time? Of course, less time. When A and B work together, their efficiency will increase, rate of work will increase, so the time required will be less than 10 days. So, how to approach this sum? We shall try to find out the individual rate of work and then the combined rate of work. So, what is the rate of work or efficiency of A? A takes 10 days to complete the work. So, total work done is their individual rate of work into total time required. And so, how to find the rate of work or efficiency of A? The total work done divided by the time taken by A, and total work done we know is always 1 unit. So, 1 by total time. So, what is the rate of work of A or efficiency of A? Rate of work of A. Rate of work is work by time. Work is 1 unit and time taken by A is 10 days. So, it is 1/10 of the work he can do in 1 day. That is his rate of work or efficiency of A. 1/10 of the work. What is the efficiency of B? R of B. B takes to complete the same work 15 days. So again, using the same formula, rate of work is total work done by T. So total work done is 1. Total work done is always 1 unit and time taken by B is 15 days. So 1 by 15, so in 1 day you will do 1/15 of the work, which is his efficiency or rate of work. 1/15 of the work he can do in 1 day. So combined rate of work will be, for A it is 1/10 of the work, that is his efficiency. And for B it is 1/15 of the work. So 1 by 10 plus 1 by 15. And that will be 33 plus 2, 5 by 30. So combined efficiency or rate of work is 1/6 of the work in 1 day when they combine together to complete the work. When they work together to complete the work, their combined efficiency 1/6 of the work. The next page. Their combined efficiency, there means A and B. A plus B combined efficiency is 5/30 means 1/6 of the work per day. So the question was, when they work together, how long they will take to complete the work. So 1/6 of the work they can do per day. So how long they will take to complete the work? You can do it like this. So 1/6 of the work they can do in one day. And what did we say? Whole work is 1 unit of work. So 1 unit of the work they will do in 1/1/6 day, that is equal to 6 days. A student may ask, why we are dividing? Because to do 1 unit of work, it will need more days. So why we are dividing? Here can you see it's a proper fraction, 1/6. If we have multiplied 1 with 1/6, the days will be less. So to complete 1 unit of work, they will need more days, more number of days. So 1 divided by 1/6 is equal to 6 days. This is the answer. So that is how we have to approach the sums of time and work. It's not from the time itself, but by calculating the rate of work. So same thing we can do with use of formula. T is equal to, we have seen T is equal to W by R. From where we know W equal to rate of work per unit time and total time to complete that work. So W is equal to R into T. From there, total time is total work done, that is 1 unit, divided by the rate of work or the efficiency. So here, when they work together, when A and B work together, R is their combined efficiency. This R is the combined efficiency. So W is 1 unit. So what is the combined efficiency of A and B? 1/6 of the work. So 1/6. This is equal to 1 into 6/1. That means 6 days. We shall use another example to make it even more clear. We are trying to explain with another example. A can do a job in 16 days and B can do the same job in 12 days. With the help of C, there is a third person, they can finish the job in 6 days. So how long C will take to finish the job if he does it alone? That is the question. And as we have just discussed, we can't enter this sum through time directly. We have to first work out the rate of work or efficiency of individual worker and then combined rate of work. So what is the rate of work of A? We have kept the formula in the box. Work done is rate of work into the total time, rate of work in 1 day, because the unit is in days. And in 1 day does R amount of work, and so in total time it will do the whole work, that is 1 unit. R is equal to W by T, that is 1 whole unit by T. Same way, T is equal to the whole work by rate of work, that is 1 by R. Let us see. So for A, what is the rate of work? Rate of work or efficiency of A Just to repeat, amount of work done in one day. So in 16 days, A does the whole work. A can do the job, means whole 1 unit of job he can do in 16 days. So rate of work of A is, if we go by the formula, work by T, total work is 1 and T is 16 days. So 1 by 16th part of the work per day, that is A's rate of work. And rate of work of B or efficiency of B. Same, total work done 1 unit, and for B he takes 12 days to complete the work. So again, work done by total time taken by B is 1 unit by 12 days, that is 1/12 part of the work per day. So what is their combined efficiency? Combined efficiency of A and B, or rate of work, that is R, combined efficiency or R of A and B is 1/16 plus 1/12. So its LCM is 48. So 7 by 48. Combined efficiency. Now when C joins the work, they can finish the job in 6 days. So what is the combined efficiency of A, B and C? It's total 6 days. So combined efficiency or R of A plus B plus C. Again, efficiency or rate of work is work by total time. Work by total time. When the C joins, they can finish it in 6 days. So work is 1 unit and time is 6 days. So 1/6 part of the work per day they can do. Individually, A does 1/16 part of work per day, B does 1/12 part of the work per day. Combined, A and B can do the work in 7 by 48 part per day, and when C comes to join, then combined rate of efficiency is 1/6 of the work per day. This is 7, 8, 48 part of the work per day. So what is the rate of work of C? What is the efficiency of C? Together ABC combined efficiency 1/6 and combined efficiency of A and B is 7 by 48. 7 by 48. So efficiency of C is this minus this. So of C or rate of, that is R, rate of work of C is total efficiency is 1/6 minus 7 by 48, and this comes to 1 by 48. 8th part of the work per day, that is efficiency of C, 1 by 48 part of the work per day. What is the question? How long C will take to finish the job alone? If we know the efficiency of C as 1 by 48, efficiency is R or rate of work, then it is easy to get the time required for C to finish the work, that is W by R or 1 by R. Let's go to the next page. From here, efficiency of C we have calculated 1 by 48. So we continue from there. Efficiency or rate of work of C. C is 1 by 48. You want to keep the formula in front of your eyes. So W is equal to R into T. So T is W by R. W is always 1 unit and by R. So if R rate of work of C is 1 by 48, then the total time T taken by C to finish the job is 1 by R. That means 1 by 48, which is equal to 48 days. So C can finish the job alone in 48 days. We can also write it like this. For C can do 148 part of the work in one day. So if we multiply this side with 48, we have to multiply that side also with 40. So 1/48 part of the work he does in one day. So to do one whole unit of the work, if we multiply 1 by 48 with 48, that is 1 unit of the work. If we cut these two, so to do 1 unit of the work, you will take this side also we multiply with 48. You can do either ways, whichever is convenient for you. You can use the formula or you can use it like this. 1/48 part of the work in one day. So to do 1 unit, we have to multiply this side with 48 and similarly that side also with 48. So C can finish the job in 48 days. An important note. Here in first part, we have used the terms efficiency and rate of work almost synonymously, although there is a subtle difference between the two concepts. So what is the difference? Efficiency is a comparative term. It gains meaning only when it is used to compare two or more workers or machines as to who can finish the work faster than the other. Thus, efficiency is more of an abstract idea that reflects the underlying concept, whereas rate of work is its practical and measurable form. Rate of work indicates how efficient one is. And as already stated, rate of work R is determined by calculating the quantity of the work done in unit time.